Okay, chapter 13 is about polynomials. And let's see if I left myself enough room on this slide here. First of all, some terminology, polynomial terminology. So a polynomial is just a collection of terms. All right, what's a term? A term are those things that are being added or subtracted. So a polynomial is something like this, maybe 5x squared y plus 2x to the fourth minus 3y. Right? Just a collection of terms. Terms are those things that are being added or subtracted. So here's one term, here's one term, here's one term. Okay? The coefficient is the numerical part of the term. So the number part of this term is 5. The number part of this term is 2. The number part of this term is -3. Don't forget the sign in front of the number is part of that number. Okay. A constant, the constant term, what if we had 12 plus? The constant term is a term without variables. So we would call this one 12 is the constant. Okay, that also means I have an extra term up here, right? Now I have 4 terms separated completely by plus and minus signs, completely by plus and minus signs. Okay, and so the coefficients, oh, we've added another coefficient. It's just that that constant, that coefficient can also be called the constant if it doesn't have any variables with it. Like terms are the terms that have the exact same variable and exponents. None of these are alike, right? This one doesn't have any variables and exponents. This has an x squared and a y. This has an x to the fourth. That just has a y. So none of those terms are alike. Like terms would be something like 3x squared y cubed and -2x squared y cubed. The only thing that can differ in like terms are the coefficients, the numerals. If you have a polynomial with just one term, it's called a monomial, right? Mono means one, okay, like a monocle. Okay, if you had a polynomial with 2 terms, it's called a binomial because bi means 2. If you had a polynomial with 3 terms, it's called a trinomial because tri means 3. Okay, so here's one term. This thing has 2 terms. The coefficients are 5 and 12. This thing has 3 terms, and the coefficients are 7, 2, and -4. In addition, -4 is the constant term. To find the degree of a term, you add all the exponents. So let's go up here. The degree of this term, since there's not even a variable, the degree of that term is 0. The degree of this term, if there's not an exponent showing, it's understood to be a 1, right? So the degree of this term is 3 because 2 plus 1 is 3. The degree of this term is 4. The degree of this term is 1. So to find the degree of a term, you add all the exponents. Now, if you want to know the degree of the polynomial, you do not add all the exponents. You find the degree of each term, and then whatever the degree of the biggest term is, that's the degree of the polynomial. So this polynomial right here is a 4th degree polynomial. Descending order means you rearrange your terms so that the degrees go from largest to smallest. They descend, they go down. So if I wanted to write this in descending order, I'd have to write this term first, and then this one, and then this one, and that one. Descending order. The degree of your terms go down. Okay, so remember, we're just adding and subtracting these things, and when you add, addition is commutative. All I have to do is remember the sign in front of the number goes with the number. So I can write 2 plus 3 or 3 plus 2. Same thing. Okay, so a little bit of terminology there. Let's see what we have. Okay, so know the vocabulary, know that terminology. Simplify each polynomial if possible, then give the degree and tell if it's a monomial, a binomial, a trinomial, or none of these. Right? So if it has more than 3 terms, it doesn't have a specific name, we just call them polynomials. These are also polynomials, but they have a more specific term. Okay, simplify if possible. The only thing that you can do is add any like terms. These things aren't alike, so I can't add them, right? It's just we already know about combining like terms. We just haven't had these exponents and things so far. So I can't simplify that any. So this is the biggest degree. So this is a 4th degree polynomial. It has 2 terms, so it's a binomial. Okay, they didn't ask this, but if it did ask what the coefficients of the terms are, the coefficients are 2 and 7. Now this one down here, oh look, they're all e squared. They're like terms, so I can add them all together. If I have 3 of these e squared, then whatever they are, right? 3 of them plus 5 more, I can add that together, and that's 8 e squareds. Okay. Oh, now I can combine these because they're alike. If I have 8 of these e squared things and I want to take away 9 of the same things, I would have negative 1 e squared. And remember, if there's a 1 there, we don't really have to put it. So now this degree is a 2nd degree polynomial, and more specifically, it's a monomial because it has 1 term. The coefficient is negative 1 because I know if there's not a numeral written, it's understood to be a 1. Okay, so 2 things we can do with polynomials. Just like the expressions we've already worked with, you can either evaluate them or you can simplify them. You cannot solve them. I don't have an equal sign. Right? There's no equal sign in this. I can't solve it. But if you are told what the value of the variable equals, you can plug it in and then do the math when it's just numbers. So if it says when h is negative 3, that just means I'm going to rewrite this. But every time there's an h, I'm going to replace it with negative 3. And now, when it's all numbers, I can just do my math. And I got to do it in a particular order because there's more than one operation, which means, since there's nothing inside the parentheses to do, exponents. Okay, so negative 3 to the 4th, well, 4 negatives is going to be a positive. And 3 times 3 is 9. And so 9 times 9 is 81. Same thing here, 2 negatives is going to be a positive, and 3 times 3 is 9. Now 4 times negative 3, and then plus 7. So 5 times 81, that's 405. Negative 3 times 9. Double signs, since they're opposite, it's a minus. Okay, so 405 minus 27. If we have to go over and do that math, that's fine. 405 minus 27, right? Nothing to borrow from, so I got to come all the way over here and borrow. Now that that's a 10, I can borrow. So 15 minus 7 is 8, 9 minus 2 is 7, and 3 minus 0. Okay, so now we have 378 minus 12. 8 minus 2 is 6, 7 minus 1 is 6, 3, and then plus 7. 6 and 7 is 13, 7, 3. So this is 373 when h is negative 3. Then it asks me to do the same thing except let h be 2. Okay, so if I'm evaluating a polynomial, I just replace the variable with the information I'm given. So I'm going to change every one of those h's to a 2. Okay, 2 to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16. 2 times 2 is 4. 4 times 2 is 8, and a plus 7. 5 times 16 is 80, minus 12, plus 8, plus 7. So 80 minus 12 is 68. So we'd have 68 plus 8, which is 76, plus 7, which is 83. Just evaluating a polynomial if we are given the value of the variables. Or we can simplify the polynomials, right? Simplify. And in order to do that, we just combine like terms. Both of these are x to the 5th, so I can combine them. 7x to the 5th minus 3. 7 minus 3 is 4. So we have 4x to the 5th. These are all n cubes, so I can combine all of those. 2 of them plus 5 of them will give me 7n cubes. 7n cubes, take away 1, leaves me 6n cubes. Let's see, now this is g to the 7th, h to the 4th, g to the 7th, h to the 4th, g to the 7th, h to the 4th. Perfect. They're like terms. Let's combine them. 4 of them, whatever it is, I don't care if it's an x to the 5th, an n cubed, or all of this. I've got 4 minus 9. That's negative 5 of these things. And then I'm going to have plus 2 of those same things. So negative 5 plus 2 is negative 3 g to the 7th, h to the 4th. Okay, so adding polynomials. It says add this polynomial and this polynomial. So that just means we have 8y cubed minus 7y squared minus y plus 3 plus 6y cubed plus 2y squared minus 4y plus 1, right? So I'm adding this polynomial plus this polynomial. But notice when I put it up there, oh, it's just like those we were working. The only thing I can do when I have polynomials up there is combine like terms. So the only thing I can add to this is if there is another y cubed. Can't add that or that or that. Oh, look, here's one. Is there any more? Nope. So 8y cubes plus 6y cubes, that's 14y cubes. Okay, now the only thing I can add to this is if there's another y squared. Oh, here's one. I suggest you find some method like I'm doing here to mark whether you have accounted for every term. Because when these things get really long, it's easy to miss a term in the middle. So I want to make sure that I've accounted for every term. -7 plus 2, well, that's -5 of these y squared things. All right, now I'm looking for just plain y's. Oh, here's a plain y. So -1 minus 4, that's also -5 y's. Just have a number left, 3 plus 1 is 4. And because I marked each one as I used it, I can tell that I don't have any missing terms there. I've simplified the entire thing. Okay, same thing down here. It's giving me a binomial and a trinomial to add, right? So it means, oh, that's just 7n cubed plus 2n, that binomial, and I'm going to add this trinomial to it. Okay, so I'm looking for another n cubed. There's not one, so that just stays 7n cubed. Okay, the only thing I can add to this is if there's another n. Oh, here's one. So 2n minus 9n would be minus 7n's. Okay, and here's an n squared. There's not another n squared. And then I can tell that I have not yet taken care of this number, so don't forget to add that. Okay. Let's try it again. So add this trinomial and this trinomial. So I've got 2n to the 4th minus 7n cubed minus 4 plus, now be careful, that's -5n to the 4th minus 8n cubed plus 10. And remember, if we have those double signs, we do not want double signs. If the signs are different, it just means it's a minus. Okay, so is there another n to the 4th? Yes, no more. 2 minus 5, that's -3 n to the 4th. Let's look for n cubes. Oh, here's one. -7 minus 8, -15 n cubed. Okay, just a constant term left. Oh, and here's a constant term. So 10 minus 4, +6. And once again, at a glance, I can tell I've used every term. Okay, now it wants me to add this trinomial and this binomial. So 7p cubed minus 9p minus 4. And then I'm going to add 5p minus 1. Okay. There's not another p cubed term, but there is another p. So -9 plus 5, that's -4 of those p's. Here's a constant, -4 minus 1 minus 5, and I've used every term. Okay, now we're subtracting. So you know when those minus signs are involved, we got to be extra careful. This says perform the subtraction. Okay, so it's a binomial minus a binomial. First thing we got to do is get rid of these parentheses. Now, when there's not a number written, it's understood to be a 1, right? So if there's not a number here, It's really a negative 1. So when I distribute 1, it doesn't change anything. But negative 1 being distributed makes that negative 6x, and negative 1 times negative 4 plus 4. So remember, if you're subtracting polynomials, you got to subtract every single term, not just the first term. Okay, and then we have 3x minus 6x, and then once it's just a list of terms out there, right? So adding and subtracting is really the exact same thing. You just get rid of your parentheses. Okay, 3x minus 6x minus 3x minus 5 plus 4 minus 1. Okay, be careful when they throw in English. It says subtract this trinomial from this binomial. That means I'm starting here. Subtract this from that. So be careful how you write it. This is 7y cubed plus 8. And then I want to subtract this entire trinomial. Okay, which means now my first step is to get rid of the parentheses by distributing that negative 1. So 7y cubed plus 8 minus y cubed minus 4y squared and minus 1 times minus 2 plus 2. Okay, so I have a 7y cubed minus y cubed. That would be 6y cubed. I have a plus 8 plus 2. That would be a plus 10. And I have a minus 4y with no y squareds, with no other y squareds. I've accounted for every term. Okay, so I got a trinomial. It's a third degree trinomial. Its coefficients are 6, 10, and negative 4. And the constant term is 10. It is not in descending order. This one is in descending order. This one's a binomial. Coefficients of negative 3 and negative 1. Degree of the polynomial is 1. Okay. So what I need to do first? Get rid of parentheses. If there's a 1 out front, it doesn't change anything. But this negative 1 needs to be distributed. So minus 6 minus 4m plus 7m squared. This is a positive, so a positive 1 doesn't change anything. And notice, really, we're adding and subtracting polynomials here. I've got 3 trinomials. I got a trinomial, subtract a trinomial, add another trinomial, but it's just a matter of combining like terms. Get rid of your parentheses, and then adding and subtracting is all exactly the same. So a constant. Here's a constant. Here's a constant. So I can add all those together. I'm going to add the 9 and the 2 first. So that's 11 minus 6 is 5. Okay, now here's an m. Here's an m. And here's an m. Negative 3 minus 4 is negative 7. Minus 1 is negative 8 of those m's. Here's an m squared. Here's an m squared. Here's an m squared. Okay, so 5 plus 7 is 12, plus 3 is, excuse me, is 15. Okay, one more. Okay, 2 more. Add or subtract as indicated. It's the exact same thing. You get rid of parentheses and combine like terms. Okay, I'm adding here. So because there's a 1 out front, it's not going to change anything. Okay, I need a 6C. I mean, not a 6C, I need a C. Nope, nope. Oh, here's a C. Nope, nope. 6C plus 3C. 9C. Now I need a CD. CD. 9 CDs minus 2. 9 minus 2 is 7 CDs. Now is there one that's just a D? Just a D. 1D minus 4D minus 3D. Okay, same thing here, except when I get rid of the parentheses, I really have a negative 1 out front, so that's going to change all my signs in that second trinomial. So I'll really have minus 5 a squared b plus 3ab minus 7b squared. Okay, I need an a squared b. That's an a, b, a b. There's an a squared b. 2 minus 5 minus 3 a squared b. Okay, now I need an ab. No, here's an ab. Minus 4 plus 3, so minus 1. And now a b squared and a b squared. B squared minus 7b squared minus 6b squared, and at a glance I can tell I've accounted for each term. Okay, let me know if you need anything.